The purpose of this video is to walk through our kind of the introductory materials and the procedure for the measurement and density lab here in Chem 105, and to also then use that information to help us complete the pre-lab assignment. So in this particular lab, you will be working on your own. And the primary idea behind what you'll be doing is you will be looking at measuring a couple of different things using some different instruments. They can be things like rulers, graduated cylinders, beakers, balances, those kinds of basic tools. And what we're really going to be practicing in this lab is how to use those tools correctly and how to measure on those tools both accurately and using the correct level of precision, the correct level of significant figures. So before we get into kind of the procedures, let's just kind of walk through a little bit about what we're talking about. Ultimately, we are making a discussion here about accuracy and precision. Accuracy, we can think of accuracy as being simply the ability for a measurement to actually measure what it's supposed to measure. So if I have an object, if this pen is 4 centimeters long, which it's not, but if I am measuring it and it's supposed to be 10 centimeters and I measure it at 10 centimeters, then I know that my measurement is accurate. Whereas if I used a ruler and this 10 centimeter pen ended up being only 7 centimeters, then we would know that we have an accuracy issue with the pen and we would need to make an appropriate adjustment. So that's accuracy. Precision kind of comes in 2 forms. The first precision form that we often talk about is repeatability. You can think about this, if you weigh yourself on your scale at home and the first time you step on it, it says you weigh 200 pounds. And the second time you step on it, it says you weigh 210 pounds. And the third time you step on it, it says that you weigh 207 pounds. Well, there's a lot of variance between those measurements. Your bathroom scale isn't terribly precise, which makes you call into question its accuracy at the same time. Because which measurement do you actually believe? Do you believe the first one, the second one, or the third one? So that's one form of precision. Now, more often than not, when we're measuring things kind of manually, we don't usually have to worry about that kind of precision very often, unless we, as the experimenters, are making mistakes in terms of how we measure something. So if I want to measure out the volume of this cup, and I pull out a measuring cup and I pour water into it, and I measure it, and I look at it and say, okay, that looks like 4 cups. And second time I pour it into the same container, I go, oh, well, that might actually be 3.8 cups. The instrument itself hasn't changed. The only thing that has changed is my observation. And so that would call into question my abilities to read the glassware accurately. It could also call into the example and into effect the other kind of precision. And with the other kind of precision we usually refer to here is the exactness of a measurement. And what we mean by that is how well can we measure whatever it is that we're trying to measure. So if I'm using a ruler, how many tick marks am I given to help me to make an appropriate estimate? Because remember, every single measurement that we take has to have one and only one estimated digit. So what does that look like? Well, it depends on what it is I'm using. If I'm using one type of ruler that has a lot of tick marks on it, then I'm going to be able to read that particular measurement a lot more precisely because, let's say that I'm able to read the length of something to 2 decimal places. Well, that means that not only can I read to those 2 decimal places, I can also estimate a 3rd decimal place in between the tick marks. And that's going to give me a lot more precision in the measurement I'm taking than if I have a ruler that reads to 1 decimal place or 0 decimal places. So precision can kind of have dual meanings there. We can talk about it in terms of reproducibility, and we can often talk about it in terms of how closely, how exactly can we make a measurement. Now, and a lot of times those worlds cross over. And where we'll see that in this particular lab is we will be measuring the same amount of water using 3 different volumetric vessels: a beaker, a graduated cylinder, and a flask. And what you'll see in those 3 objects is that they have varying levels of precision. The graduated cylinder, you're able to read every single milliliter on the scale from 0 to 50. Whereas with the beaker, you might have 1 mark every 25 milliliters. And on the flask, depending upon what kind of flask, it might be every 25, it might be every 50, it might be whatever. So that level of precision, the more tick marks that we have, the more likely it is that we would assume that we're going to get an accurate measurement and an exact measurement from that graduated cylinder compared to the others. Now, we can drill down on this idea of precision using a calculation known as standard deviation. And we're not going to get into the basics of the statistics for how to calculate that. That's not really important to us. What we need to understand is that when we have precision, standard deviation is going to be small. It's going to be low. When our precision is not so great, we're going to have a lot of variance. And so you got to think about that bathroom scale kind of idea. If you've got a really good bathroom scale, it's going to have a relatively low standard deviation. It might read you as, being half a pound different each time, as opposed to 2 or 3 pounds different each time, or as opposed to 5 to 10 pounds different each time. That level of variance, that standard deviation that we're talking about, the smaller, the better in terms of precision. As we mentioned before, accuracy is how close you are to the actual value. And what we can use for that are standard, percent error calculations, where if we know what the actual value is or what it should be, then we can compare what we had versus what it should be and do was basically a percent difference, where we're taking the difference between the 2 values and dividing it by what we know to be true. And that ratio would give us a decimal, which if we multiply it by 100% would give us a percentage. And so that's one aim of this lab, is to look at the ideas of accuracy and precision, start to get an idea of how to recognize when certain events are going to give us better accuracy, better precision compared to others. Now, the other thing that we want to really focus on and stress is the idea of reading things accurately. And for that, what we have to again remember is that all measurements will have every known digit measured plus 1 additional estimated digit. So putting that into action here, if I'm going to measure this arrow, I can see that the arrow starts here at 0 and it ends here just before the 9. Well, I know definitively that it is greater than 8, but less than 9. So when I'm measuring the value of this arrow in inches, I know it's going to be 8 inches. And I know it's not going to be fully 9 inches. This X, this is a value that I do not know. There are no other tick marks to guide me there. So the only way I can really kind of get a handle on it, get a hold of it, I have to be able to do an estimate. And so I look at this and I try to give a kind of a best estimate. Okay, it's definitely more than halfway. It looks like it's more than 3/4. It's practically 9. I'm going to call it 8.9 inches. Now you may be looking at that and say, well, 8.9 inches, that seems a little bit excessive. Maybe it's not 8.9. Maybe I'm more comfortable saying it's 8.8. That's fine. That's actually completely within known, well-practiced ideas. That's why it's an estimate. Now, you are needing to make your best possible estimate, but yeah, it's definitely an estimate. So you might look at that and say 8.8. I look at it, say 8.9. There's probably going to be a little bit of variation between our measurements. The more precisely we can read that measurement, we can read that ruler, the less variance there's going to be, because we're going to have less guesswork to do. But having a little bit of variability, that's perfectly okay. So that's on a ruler. What about if we're measuring a liquid? Well, when we measure a liquid, you have to remember water, because of its surface tension, it has some adhesion qualities with glass and with some other materials. It's going to slightly curve up on the walls of the stuff that we are putting it with. And so it's going to kind of create this thickness, a little bit of a bubble almost, called the meniscus. And at that meniscus, we want to read that meniscus at the bottom as opposed to where it's curving upward. So you have to get down on eye level with whatever it is that you're measuring. And so this kind of has blown that particular thing up. And we can look at this particular measurement here and say, okay, each one of these tick marks is 1 milliliter. So it's less than 70, it's less than 69, it's less than 68. It looks like it's right on 67 milliliters. And so 67, we would know precisely. The X would be our estimated digit. And so since it falls on that line, I would call that 67.0 milliliters. Now, again, you might look at this and say, well, hold on, Dr. Bruck. That doesn't quite look like the meniscus is on the line. Maybe it looks like it's a little bit below the line. Well, again, that's an easy adjustment to make. You would say, okay, well, it's not quite 67. It's actually 66, but it's really, really close. Maybe it's 66.9. Depending upon your eye angle and the parallax, you might look at that and say, actually, that looks like it's a little bit above the 67. You know, maybe it's 67.1. And again, that little bit of variation is completely okay. That's why we do these estimated digits. That's why estimation has to exist, because without it, we're, you know, kind of at the mercy of whatever instrument it is and our own kind of personal whims. So this has to occur the way that we're presenting it. So the last thing that we want to look at here is just the, you know, kind of the last thing that we're doing. One of the kind of things that we're going after is density. And for density we know as mass over volume. And in mass, now mass we're going to use a balance for. With a balance, we don't have to do an estimation because the estimation has already been done for us. That last digit that you get from a balance, that is an estimated digit. And so that takes care of the guesswork for us, which is why if you look on a balance, regardless of how many decimal places that balance has, it's going to tell you on the side, plus or minus 0.01 grams or plus or minus 0.0001 grams. And the reason it's going to tell you that is exactly that. It's going to tell you that so that you know, hey, there's estimation here in that last digit. So you might see a little bit of wiggle on that last digit, on that last decimal place. As far as procedures go, looking at the procedure itself, you can see that there are 3 parts to this. There is going to be a part where we are going to be comparing the precision of a 100 milliliter graduated cylinder, a 150 milliliter beaker, and a 125 milliliter Erlenmeyer flask. We're going to be measuring 50 milliliters of water in each, and then we are going to weigh the 50 milliliters of water on the balance and compare. So what you want to make sure that you do when you are measuring everything out, make sure that you are measuring it properly. And so for some of these, like for the beaker and the flask, the volume gap between the lines of measurement may not be all that precise. So if each mark is 25 milliliters, the best you can do is, well, measure out the 25 milliliters. Get it as close to the 50 line as you can, what you feel comfortable with, and kind of take it from there. Or in the case of some of these, where maybe you have a 40 mark and a 60 mark, and there is no 50 mark, then you really have to guess where it is. So, examine each of those pieces of glassware closely, and make your predictions and kind of go from there. In part 2, you're going to be using a ruler to measure the dimensions of a piece of paper. And then you're going to convert those dimensions into an area. And so we're going to do a little bit of measurement practice. We're also going to do a little bit of calculation and significant figures practice as well. And then finally, in part 3, we're going to teach you the volumetric displacement method. So learning how to determine the volume of an object that may not be easily measured, and doing so in a way that is pretty easy to do. And then using that volume and mass information to calculate the density, and using that density, we can try to figure out what it is, at least in terms of what it's composed of. Okay, so those are the 3 parts that you're going to do. Let's look at the pre-lab information. Okay, so in the pre-lab, we're asking you to do just a few things. So first of all, I want you to write a purpose statement for this lab. So here's what I don't want you to do. I don't want you to go into the introduction section here and look at these lab objectives and say, oh, okay, this is the purpose of the lab. The purpose of the lab is to do these 4 things. That's not what I'm getting after. Yes, these are objectives. These are things that we want you to learn how to do, but they are not the whole of things that we want you to learn how to do. So what I want you to kind of get into the mindset of, and we're going to be working on this throughout the semester, is can you identify some realistic purposes for why we do what we do? So in this case, you might look at the purpose of this lab is to gain experience with learning how to measure substances properly using different types of glassware and different types of instruments. Notice that's not one of these. I mean, it's kind of related to number 1, but I've made it more specific. I've made it more personalized to the experiment and the procedure. It shows that I've actually read what I'm supposed to do, and I kind of have an idea of what I'm going to do going in. So again, don't look at these objectives as, oh, this is my purpose statement, I just need to rewrite it. Kind of go through the procedure, go through this introduction, and just kind of pull on, okay, what is it really that we're trying to get after? What are we trying to do here? And I think if you go from that perspective, you're going to get a lot more out of these labs, because you're going to be able to kind of identify, okay, this is the main idea. This is the point. This is why we're doing this. So that's question number one. In question number two, I'm asking about the difference between accuracy and precision. Already discussed that in the video. You can find those definitions here in the introduction section. When you measure how many estimated digits should be in the measurement, talked about that earlier here as well. The answer there is 1. Every measurement has 1 estimated digit. And then finally, look at this picture and tell me the correct volume based upon where that meniscus is, using the correct number of significant figures. I'm not going to tell you the answer here. I want to see what you come up with, see if you've been paying attention throughout the course of this video. So that's it for this pre-lab assignment. It's really pretty straightforward and easy. Hopefully this video kind of helps to get your head around the kind of the purpose and why we're doing what we're doing. If you have any questions about anything, feel free to reach out to me. Otherwise, have a good day, and I will see you in lab.